Alright, so another antiderivative involving trig identities. This time we're doing odd powers of sin x and cos x. Jumping straight into it. The integral of cos cubed x with respect to x, that's an odd power. Now usually the way that you get around these odd powers is by using a trig identity, and I can write that as cos squared x times cos x. Cos squared x times cos x is cos 3x. Now, and I should remember that cos squared x, if you don't remember any other trig identity, you have to remember that cos squared x is equal to 1 minus sine squared x. So now I have the integral of 1 minus sine squared x cos x with respect to x. From there, it's really, at least this question is really straightforward, because you'll be able to let sine x equal u, and if you let sine x equal u, the derivative of sine x is cos x, and the derivative method that we've been doing to death, you'll just be able to apply that. Alright, so there's that one done. Now, as you can see, really straightforward. Once you spot the fact that because there's an odd power, you've got to use our Pythagorean identity and then move from there. Alright, so here's another example here. The integral of cos to the 4 2x sine to the 3 2x with respect to x. Now we've got an odd power. Obviously we can't have an odd power. We need to get rid of it as quick as possible. Cos to the 4 2x sine 2x sine squared 2x with respect to x, and we can replace that with sine, and then that's going to be times 1 minus cos squared x. Alright, will I leave it like that? Yep, that'll do it. So, we've got, that should be cos squared 2x, shouldn't it? So, I've got cos squared 2x here, I've got sine 2x there, I've got cos 4 2x there. I need a u, I need to let u equal something here. So you've got to let u equal something where the derivative is present here. So we've got like a cos squared 2x. If I let cos 2x equal u, that's going to give me u squared. And it looks like u squared, and then that's going to sort of become u. We've got a derivative. So I'm going to let u equal cos 2x. And then the derivative of u with respect to x is 2 sine 2x, negative, sorry. Now, we should be able to rearrange that to make dx the subject. Negative 2 sine 2x, and we should now be able to sub all of that in. So we've got, right, so then it's the integral of, now cos 4 2x, you might be tempted to put that straight in, but u is cos 2x, and cos 4 2x is cos 2x to the power of 4. So it's going to be u to the power of 4 sine 2x times 1 minus, that's u squared, then du over negative 2 sine 2x. Now the 2 sine x, sine 2x and the sine 2x is going to cancel out. This negative 2 on the bottom is like negative 1/2. So we can take that negative 1/2 and put it out the front. So now I have negative 1/2 integral of u to the 4 bracket 1 minus u to the 2 du. Now, if I expand those brackets, integral of u to the 4 minus u to the 6 with respect to u. Now I can just use my rule to integrate that. So it's going to be negative 1/2 u to the 5 over 5 minus u to the 7 over 7, the end plus c. And then I can maybe expand that. I'm going to try and not expand that, and instead I'm going to put back what I had, which is cos. Actually, no, I won't. I won't expand that yet. I'm going to bring u out as a common factor. So it's going to be negative 1/2 u to the 5 bracket 1/5 minus u to the 2 1/7. So I'm just taking out the lowest u. And now, maybe, I'll put back in whatever u was. U was cos 2x. So it's going to be negative 1/2 cos to the 5 2x 1/5 minus cos squared 2x over 7. And then we'll just do a plus c on the end. Now there are other ways to do that, and you could probably group this together if you wanted to inside of those brackets just by adding those two fractions together. You could also expand this out. There are a few different ways to show that. But there's our odd powers of sin x and cos x.